Welcome. Welcome to vsdevelopers.io. Today's topic is integers. You might be thinking, come on, Venky, don't just go too basic. Right? Integers, who doesn't know it? Right? Every programmer, even any role in software engineering, they are aware of what are integers. Forget about software, right? If you go and ask about a fifth grade student, they would say, what are integers? Now, when you are solving a problem, as we have been seeing in many videos of vsdevelopers.io, problem solving is the most fundamental prominent thing, right? So how do you solve the problem? First, you understand the problem and then translate it into algorithm and then to program. And while you are translating, you will understand the problem, okay, whether the asked problem requires an integer declaration or a real number declaration or a string declaration, character declaration. So you must identify the data type, isn't it? So when you identify the data type as integer, say as simple as print numbers from 100 to 1000, some numbers 100 to 1000. So 100 and 1000 are integers, we know that. So you would declare a number, starting number, as an integer. Now what is that more to talk about it? So right, so when you are dealing with problems that involves integers, you would declare an integer variable. That's all about it. Yeah, welcome. So welcome to the the other side of the world of integers. How integers could be a nightmare, how integers could go to the state where arbitrary code can be executed in your program if you don't code them right, if you don't code them secure, right? So integers typically range from your 16 bytes, right, and 32 bytes, 16 bits, 32 bits, 64 bits. And that is what brings in the modifiers, right? The size of an integer. You call it short integer, called integer, you call long integer. And C++11 onwards, you have long integer as well. So you can make the long double. So long integer. So you have, these are these modifiers in relation to size. Now, there are modifiers relation to your signedness. That is, signedness is what? Unsigned or signed. If it is a negative number or a positive number. Why would it make any difference? If it is a signed number or unsigned number, why should we particularly declare about it? Yes, one is, when you declare an integer, the default modifier it assumes is signed. So you can store negatives, negative numbers, and positive numbers. And then when it comes to unsigned, you can only store positive numbers. You know that the size is doubled because you're bringing the entire capacity of negative numbers towards positive. So you will use the whole 32 bits to store a larger number than what you would store in a signed integer. Well, is that the only thing? No. In some of the CPUs are designed to process unsigned integers faster than signed integers. Therefore, when you know that your data type is going to be unsigned, you're not going to accept any negative numbers into a particular variable, you must declare it as unsigned for the speed of your program and also the size where you are doubling it, right? That's why you go for the sized modifier of unsigned integer, and the other one is signed integer. So you have seen integer, one side is your size of them, short or long, other side the signedness, unsigned or signed. And you can combine, mix match this sizedness and the sizes. Okay. So you can combine these signedness and sizes, like unsigned long, right, or signed short. You can mix and match these as per your needs. Well, this is all very basic, we know it. Tell me something new, Venky. Not this one. Okay. Well, so now let's see what could go wrong when you are declaring variables or when you are dealing with them. What happens? You are inside a program or inside a loop and taking a user input and doing a simple arithmetic operation. As you don't know the input value what user enters, but you have an division operation you got to do. So you have x by user input. That is, let's say, variable a. So x by a is coming from user, x is a fixed number, and user entered value as 0. What happens? What happens to a by x by 0? What happens, like x is 100 by 0, right? As simple as that. That involves only integer. That involves, if you want to declare it as a unsigned integer, yes, it's only unsigned integer. It is very simple, very straightforward, very simple arithmetic operation, division, and you are taking the user input, which you do it most of the times. The operation that you are doing is division, and you call it x by a, and a value is 0. What happens? Right? Undeterministic. That is 1. Just the simplest one. And then go about integer truncation. What happens in integer truncation? Okay, so you declared a one integer variable as short integer, but what you entered as a user input, or you are passing a parameter from other function, cannot be accommodated into short integer, that is maybe 16 bits. What happens? It gets truncated. What happens if it is truncated? Right? The solution is not what is expected to be. So the solution is going to be wrong. When the integer is truncated, you don't know why the particular output is coming. You will bang your head while debugging to try to resolve the problem, right? So it looks very simple while writing the code. Okay, it's a short integer. I always declare I save 2 bytes. Yeah, you do save 2 bytes. But if the user input is coming, which the size, if you don't control it, bang it, right? So you are going to truncate the integer, and the outcome is going to be undeterministic. That is B, right? A divided by 0, B integer truncation. Then what? It is integer overflow. We have seen the truncation. You can now see integer overflow, or you also call it as wraparound. Right? So when you have to store a particular number, and when you store, when it is pushed a larger number than it, either it wraps around or it overflows. When it overflows, you don't know what number comes out. At least in wraparound, you can be particular, you can be deterministic about what it wraps around to. So make sure you don't let your integer overflow. That is the C. And the D, it's about integer conversion. How about you declared one integer as long and the other integer as short, or you declared one integer as short unsigned and then long signed, and you try to convert one to other. Guess what happens? Yes, can you relate it that it can be catastrophic? The outcome, the output can be undeterministic, right? So incorrect conversion is something that you should be aware of while you are coding. Don't assume. So you be clear about what you are converting it into. Make sure that you use typecasting. Anyway, we will talk about the solutions later. Today we are only talking about how integers can be catastrophic, how integers can be nightmares for the developers and while debugging. Then the other one, which is important, right? How do you know the ranges of integers? So there are constants declared in every programming language, right? So the lower limit, upper limit, you have numeric limits. Now, if you compare the range comparison without minimum check, that is going to be a disaster as well, right? So you must always check the range comparison, right? So you with minimum value. If you don't know if the minimum value is going to be lower than what it is assigned to. So therefore, if you notice any system programming code, right, there are many open sources where you can go and check the minimum value check is always done before actually use that number into operations. Right. So these are the 5 numeric errors with integers possible in your day-to-day coding. Either C, C++, Java, or even few other languages are prone to these numeric errors. What these numeric errors can do? Yes, they can do like your program would crash. Is there anything more catastrophic than crashing your program? No, crash is the biggest error that could happen, because your application is down, your service is denied if a customer is requesting for service. So it is the topmost category of error if a crash happens, right? So you have these 5 numeric errors in mind, and code with caution, code securely. First, A divide by 0, B integer truncation, C integer overflow or wrap around, and D incorrect conversion between the numeric types, and 5 numeric range comparison without minimum check. Right? So integers are very powerful. We use it in, day out, every time. And then while you're coding, or enhancing the code, existing code, or maybe you're just bug fixing, make sure you follow these secure coding principles, and then write better programming, build better applications, safer and secure applications. All right, so that's all for today. And next, upcoming videos, we'll discuss how do we resolve it. Right? What is the error and code snippet, and then the resolution and the resolution code snippet. For more information, log on to vsdevelopers.io, and then you can also log into join our Telegram group, where these kind of videos, information is shared across. Thank you for watching. Bye bye.